Question 8, part A and part B. Part B is the question that I told you. Huh? Yeah. Why? Show that triangle BMO is congruent to triangle CNO, giving a reason for each statement. And you should be very happy to see congruency or similarity questions in O levels or N level because they are 3 marks. But this one, this particular reason that last year students struggled with it. How to show that it's congruent? So they tell you that A, B, C, D are points on the circle, and M is the midpoint of AB, and N is the midpoint of CD. And they tell you further that AB is equal to DC. So many students don't remember this reason. So like I said, it means Venus went through this with you already. I told you this is important because it came out last year. And a lot of students forgot this particular reason. What's the reason here? I want to show BMO, which is this triangle, equals to CNO, which is this triangle. So the first thing is angle ONC is equal to angle OMB, which is equal to 90 degrees. Why? What is the reason? Something like that, but not tangent. It's not a tangent. Hello. It's called a perpendicular bisector of chord. So this is your perpendicular bisector of equal chords. Right? So once you figure out this is 90 degree, then you ask yourself what's the easiest way to prove. You can prove that OM is therefore equal to ON as well for the same reason. Perpendicular bisector of equal chords are equal. Okay. Then AB equals to CD. Sorry, not AB equals to CD. I have OM equals to ON, so there is one length. I have a right angle, and then therefore I use OB equals to OC because radius of circle. Are you sure it's SAS? Therefore, triangle BMO is congruent. It's not SAS. You can use SAS in this question, but I didn't use SAS. I did not use SAS. What did I use? This is RHS. Right angle, hypotenuse, and one side. This is RHS because I use this length and I use this length and the right angle. So it's not SAS. There is no SSA congruence one, please. So this is RHS. You could also have used SAS. SAS. MB equals to NC. So you could have used SAS. Because there is no property that is ASS. SSA does not exist. It's neither a similarity nor a congruence property. And you remember that it does not exist because it makes you an S, okay? I have no comment to that. Now, radius of the circle is 4 cm and angle COD is 1.8 radians. COD, where's COD? COD is this angle. Calculate the length of the major arc. These are major arc, not minor arc. Where's major arc AB? Major arc AB is this arc. Every time got student go and find the wrong arc because never read the question. This arc corresponds. How to find this arc? This arc corresponds to which angle? It corresponds to this angle. Okay. So how to find the angle? If COD is 1.8 radian, COD is the same as which angle? COD is the same as this angle, right? Because congruent triangles, right? And because of perpendicular bisector, this angle will also be 1.8. So all these angles will all be 1.8, correct or not? They say which angle is 1.8? COD. Oops, my bad. Oops. Yeah. COD. COD is this whole angle. So this is 1.8. Which means that this will actually be 0.9, 0.9 because your perpendicular bisector here is also an angle bisector. Okay. But in this case, it doesn't matter. You just need to know that if COD is 1.8, that means angle BOA is also COD will be congruent to BOA equals to 1.8 radians because corresponding angles of congruent triangles. Do you need to prove the congruence? No, you don't. You are not required to prove the congruence. You know that the radius is 4 given the question. And therefore, you can find the reflex angle AOB. So reflex angle AOB is equal to 2 pi minus 1.8 radians. I won't bother simplifying this. I will just leave this as it is. And therefore, major arc AB is equal to, what's the formula for arc length? R theta. So radius times theta, which will give you, press your calculator, 17.933 in 5SF, although actually I won't need the question anymore, so there's technically no need to do that. Okay, so 17.9. Okay. Now, question AB is the fun question. So have you all figured out whether point R lies on the circumference or not? So this question, depending on how you solve it, will give you different answers. There are 3 possible answers. Yeah. I got a reply, but the reply doesn't really say anything. I thought I showed you all. The reply is that they are aware of the issue with the question, and they will work with Cambridge International to make sure that the grading is fair. That's all they said. Yeah. So in other words, they said nothing. I'm very sure they already realized because I'm sure they would have been bombarded. Imagine you took the paper that year, you would definitely have sent an email to Cambridge one or to SEAB one. Okay, noted with thanks. Now, anyway, there are different ways to solve the question depending on whether you assume R lies on the circumference or not. Technically speaking, because the question never said that, the correct way, I think, is to not assume. Don't assume R lies on the circumference of the circle because it's not stated. I think that is the correct way to approach the question. Okay? Therefore, what does that mean? Why is that significant? It is significant because that means you cannot use this thing called angle at center equals to twice angle at circumference. Because R is not an angle at a circumference. So in other words, you pretend that R is like this. It doesn't lie on the circumference. That is basically what I think the correct way of approaching the question should have been. But at the same time, Cambridge cannot draw the diagram like that and expect students not to assume that it lies on the circumference, right? I don't think that is very fair to the students either. Yeah. It's not an error, you see. It is just a matter of does R lie on the circumference or not? And I would solve the question assuming that R doesn't lie on the circumference. Okay, so in other words, I don't use angle at center equals to twice angle at circumference. Now, I start off by drawing a quadrilateral. You should know that this shape is a kite. Right? And then I can draw a line down over here. Why is that significant? Because I want this part over here. And I want this part over here. So that is where angle at center makes a difference, right? Because if you can find the angle at center, then it's just 26, right? Because 13 times 2, correct? If I extend the line here, if that is an angle at circumference, then naturally you will tell me that this angle here, angle at center equals to twice angle at circumference equals to 26, right? But if it's not, then we cannot do it that way. That's the difference. And given that the question is 5 marks, perhaps they never intended for you to assume that there is angle at center, there is angle at circumference in the first place. Okay? So I can use the quadrant. So maybe I let this be point T, for example. So let T be the other point of intersection. So I can find the red color area using what? Area of sector, which is area of quadrant minus area of, area of sector minus area of triangle to get the area of the segment. So I can get the red color segment, no problem, correct? It's the blue segment that is a problem, right? Because to find the blue segment, I need to find this angle. If it's angle at center, then it's very straightforward. If you have the angle at the circumference, but I don't think the question is meant to be that straightforward. So I think Cambridge didn't intend for R to lie on the circumference, but maybe some intern that they hired to draw the diagram do it wrongly. I feel like that's actually what happened. I feel like that's actually what happened. It was not intended to be anywhere near the circumference. Because if it is, right, then I don't see why the question is 5 marks, you see. Just angle at center equals to twice angle at circumference, what? Then very easy to find the area of the two sectors really. The area of the two segments, what? Why would it be worth 5 marks? Correct or not? So I suspect that it's not meant to be the case, and that's why it's 5 marks. So, but that doesn't leave us, that leaves us with the question, right? How then do I find this angle over here? How? Just fine lah. You tell me how lah. If I don't use angle as center equals to twice angle as circumference, then how do I find? I would have to use cosine rule. And that would make sense why it is 5 marks. Why would I need to use cosine rule? Because I know that this is the radius, all right? And therefore, this is an isosceles triangle. And therefore, I would know that this angle is also 13 degrees, right? Then I can actually know, do I need cosine rule? I don't even need cosine rule. Then scratch that. So I can now find angle as QR. Agree? No, wait, I cannot assume that because that would assume that that's on the radius. Never mind, I'm dumb. It's not on the circumference, so it's not an isosceles triangle. Stupid diagram. Hey, what? That will give me the red color part lah, correct lah. Yeah, but I don't have the area of the sector ma. I cannot find the area of sector because while I know this length, I know this is 7 and this is 7. I know this is 4.5 and this is 4.5. I don't have this angle over here. And you cannot use area of center if I assume that R doesn't lie on the circumference, then it does, then I cannot use that, right? So how are you actually supposed to find? What can you use? You can use sine rule. What? You can use sine rule. This is the triangle, right? So you realize now that the answer will be very different if you use sine rule versus if you were to. If it's a circumference, then this would straight away be 26 degrees, right? Correct or not? But if I use sine rule, and I'm going to use sine rule to demonstrate to you. And interestingly, for this question, if you use cosine rule, you will get a different answer for the angle. Why? Because fundamentally, a triangle like that cannot exist. That's the problem. That's why if you use sine rule or you use cosine rule, you get different answers. Because the mathematically speaking, the triangle couldn't exist in the first place. So what must have happened to Cambridge is that they must have accepted a range of answers for this question. That would have been the logical thing to do. So if the student use angle as center equals to twice angle as circumference, they accept it. If the student use sine rule, they accept it. If the student use cosine rule, they accept it. But I'm going to use sine rule here using this triangle because I got 2 lengths and I got the 43 degree, right? 2 lengths and 1 excluded angle, I can use sine rule, right? So by sine rule, they will accept it only if you solve it correctly lah. So you still have to, if you use that particular method, you still have to show that your workings and all that are correct lah. Then they will still mark normally long. So sine, but I cannot tell you. You should go and ask your school teachers because they will have seen the Cambridge Examiner's report. I didn't see this year's Cambridge Examiner report. But your school teachers will have seen it. So you can go and ask them exactly how Cambridge marked this question. I don't know what you're talking about. Moving on. So by sine rule, sine angle SQP corresponding with 4.5, right, is equal to sine 43 degrees corresponding with 7. Agree? And therefore, angle SQP is equal to 4.5. Sorry, I forgot my sine inverse. Sine inverse (4.5) sine 43 out of 7. Now, if you are one of those students who cannot directly visualize why it's like that, then you go and cross multiply first. Then you go and slowly work through the question. Actually, don't need to cross multiply. You just multiply by 4.5 to get rid of the denominator first. Then after that, you take sine inverse. It's in degree. The previous part, even though the question was in radian, you didn't need to change your calculator to radian. But if you did, please remember to change back to degree. Don't give me weird answers. Okay, so by sine rule, what do you realize? The angle is 26, but it's not exactly 26, right? So if you use sine rule, it tells you that the angle actually is, so it's not exactly at the center, right? It tells you that it's very near the center, but it's very near the circumference, but it's not at the circumference itself. If you use sine rule like that, correct or not? That is what the question suggests to you. But it's not exact. So it's not at the circumference. Even though mathematically speaking, there is no, in terms of accuracy, it doesn't make a difference. No, that's not the problem. The problem is if you use cosine rule, you get a different value. And you could have used cosine rule here. That's the problem, right? You could have gone to find this third length PQ over here. If you go and find PQ, you can then use cosine rule, right? And if you use cosine rule, you will get a different value. And that is where the problem with this question lies. Yeah, but you can use sine rule to go and find the length also. Yeah, but it can be done. So the problem is the application of cosine rule here will interestingly give you a slightly different answer, which is a very strange thing. Okay, but anyway, if you use sine rule, you will realize that actually the angle is, the point R actually doesn't lie exactly on the circumference, which is a very interesting thing. Okay, so answers are weird sometimes. All right, so you find angle SQP, which is 26.0 degrees in, actually, what is it in more accurate? 003, right? I will leave it in 5SF now that I think about it. Now, don't need to round off to 3SF because it's not. It's just an intermediate step. Now, once you find this angle, you will know that this is also 26.003 because they are your triangle SPQ and triangle PTQ are congruent. Okay? It is always going to be congruent because SSS. Right? So once you have that, you can go and count the shaded area. Shaded area, you want to put how many steps? Up to you. You want to do it in one step, you can. You want to do it over multiple steps, you can. I'm just going to do it one step here. I want to find the red area. What's the red area? Your segment as your segment, the red segment and your blue segment, right? I'm going to find them together. So it is your sector minus triangle. So your shaded area is equal to half A B sine 43 times 2 is 86 minus, sorry, why I put the triangle first? Half R square theta first. But please remember one thing. Is half R square theta is in radian. What would it be in? Is theta over 360 times I R square. So be very careful. We are using degree. So what's your theta? Theta is 86 degrees. Theta what is your, this 4.5 square minus half AB sine C. That is your first part of the shaded area. Then plus the second part of the shaded area is 52.006 degrees over 360 degrees times pi r square minus half AB sine minus half AB sine no space. I don't recommend in exam you all do it together. I'm just lazy. But it doesn't really matter. So you will end up with 8.027 in 4SF, which will be 8.03 in 3SF, which I think is also the same. Oh, wait. Oh. Oh. No. Oh. Wait a minute. You got 7 point something. It could be that I pressed the calculator wrongly. Who knows? Oh. Then you do it separately. I never tell you to do it in one step. I'm just lazy. You don't do it in one step in the actual exam. You do it separately. Oh, no, this is now very interesting. This is the actual TYS that you have, right? So what did Cambridge do? They changed the question. Is the answer correct? What does the answer book, let's say? 8.03, right? Yeah. Lah. So even though it's a long string of answer, my answer is correct. Lah. Please don't do this. Find them separately. Thank you very much. This is the TYS version, right? That you have. Ew, sneaky Cambridge. Cambridge changed the question when they publish it for the TYS. The original question so they changed it to a question that works lah. Very big difference. So Cambridge changed the question. They do that all the time. If there's an error in the question, right, when they publish it, they will make sure the errors are edited before they publish it. Which makes sense, but your students will feel aggrieved lah. You think too much. Okay. Yeah, so you can see that Cambridge changed the question because so now, okay, but it still tells you something. If you use sine rule here, you realize that. So technically now you can use. Actually, you can, but it is still not on the circumference. Actually, I don't know. The fact that when you use sine rule, you get 26.00 something tells you that it doesn't actually lie on the circumference. You get the logic. You will still get it wrong if you use angle as center equals to twice angle and circumference. Because you assume that it lies on the circumference, but actually if I use sine rule, I show that it does not lie on the circumference.
Then they change one.
Huh? Yeah, lah, but it's better than this dimension that gives you an impossible triangle, right? So that is what they did. They changed the question for publishing. But they do that all the time now. That's a very normal thing. If there are errors in the question for publishing, they will change the question so that the students feel more aggrieved. See, that's why it's important to have, the original copy of the paper. If not, the students go and check back. They're like, hey, this doesn't seem like the question that I remember. Now, I'm not going to go through question 9 here. Question 9 will take a while to explain. But question 9, actually, I'll give you the solution to question 9, but actually it's not difficult. Question 9, take note that this kind of real world application question for these 7 marks, right? They will accept a whole range of answers. So the marking guidance from Cambridge for this kind of question is what? What's the marking guidance for Cambridge? Anything that is reasonable, they will accept. As long as your assumptions are reasonable, as long as your calculations are reasonable. That's why the question always say this, and a lot of students don't do this. When you decide to use a particular, so let's say you decide to use a particular number, you need to explain to me why you decide to use this particular number. The question specifically asks you to justify the decisions that you made. And that's why depending on the decisions that students make, they will end up with different answers. So Cambridge, when you mark this question, as long as your assumptions and as long as your justifications are reasonable, they will accept the answer one. They are very friendly about it. So you don't need to worry too much. And they are quite lenient in allocating marks for this particular part of the question. So never leave your real world application question blank. Which a lot of students, I don't understand what the question wants me to do. I just leave it blank.
Say how much should I charge one bottle? I want to take 50 after no profit. And then one bottle for $4. Then somehow I managed to charge them only 98 cents. You suggested I'll pay like $15.
But the school answer suggested answer is $15.
And I still get 3 marks.
No, I will look at the answer and tell the school, you go and suggest to the supplier to sell a bottle of water for $15. You see who will buy it.
Or something.
I don't think 15 is a reasonable answer. I don't think 15 will be a reasonable answer. $5 something, yes. If you tell me a bottle of water should cost $15, that is definitely not what Cambridge would definitely consider to be a reasonable answer. Okay, if you can convince people to buy bottled water for $15 each, sure, be my guest.